Let's try a little momentum problem. Let's say you have a car that has a mass of 715 kilograms and is moving 2.25 meters per second towards a van that's at rest and has a mass of 1055 kilograms. So, can you guys find the velocity of the car and the van after the collision, assuming that the collision is elastic? So what are we looking for? The velocity of the car and the van. So car and van after the elastic collision. Okay, so you guys can stop the video and try it out, but I'm going to go ahead and solve it. So, how I like to think of it. Well, the car and the van share a center of mass somewhere between them, right? Now this center of mass in this case is moving, and we can calculate its velocity. What's the total amount of momentum in the system? Well, the van's not moving, but okay, we can take it into consideration. Total momentum, P, will be the sum of the mass, this mass times velocity, and this mass times velocity. So m1v1. So this is P total, let's say PT. m1v1 plus m2v2, which is m1v1 is 715 kilograms times 2.25. Oops. 2.25 and plus m2v2. Well, v2 is 0, so that term would just cancel out, right? So 715 times 2.25. Let's try it out. 715. Oops. Bring that into view for you guys. 715 times 2.25. That's 1608.75. 1608.75. Actually, I think I'm going to use my own calculator for this because it gives me fractions. So, yeah. Anyways, so that's the total momentum in the system, right? But remember, the center of mass can be considered as a point where the total mass of the object, well, you can think that the total mass of the system is kind of balanced on the center of mass, or acts from the center of mass. So, whatever the velocity of the center of mass is, times both the masses add together, will give you the total momentum, right? So, the total momentum, which is 1, 6, and this is in Newton seconds, by the way, 1608.75 Newton seconds, is equal to whatever the velocity of the center of mass is, so center of mass, times the total mass, so 715 kilograms plus 1055 kilograms. So if we divide both sides by the total mass, we'll get velocity of the center of mass is, and I'm just going to do this on my own calculator. You guys go ahead and do it on yours. So divided by 715 plus 1055. And that's going to be this fraction. Yes, I have a cool calculator. 429 over 472 meters per second, which is approximately 0.91 meters per second. Alright, so that's the velocity of your center of mass. Now the cool thing is, in an elastic collision, let's say you have your center of mass. I'm going to kind of visualize everything as relative to the center of mass. So instead of relative to the van, which is at rest, we'll say the center of mass is at rest, right? Because physics works in every inertial frame, right? So let's say that your center of mass is actually at rest, and the van is approaching the center of mass, and so is the car. Now at what speed is the van approaching the center of mass? Well, remember, the center of mass is moving at 0.91 meters per second, and the van isn't. So if you look at it from the perspective of the center of mass, the van is actually moving towards it at 0.91 meters per second. So Oops. So 0.91 meters per second for the van. What about the car? Now, the car is approaching the van at 2.25 meters per second, but the center of mass itself is moving at 0.91 meters per second. So you have to subtract it. So 2.25 minus 0.91, and this is going to be in meters per second, equals 2.25. Yes, I'm using a calculator, I know. It's sad. Ooh. 1.34 something, blah blah blah. I actually used the fraction of my calculator. Meters per second. So the car is approaching the center of mass at 1.34 meters per second. Now the cool thing about elastic collisions is that after they collide, they're actually gonna, so this fan is approaching the center of mass at 0.91. It'll be receding at 0.91 meters per second, and the car will be receding at 1.34 meters per second, which is pretty cool. So yeah, that is a rule. When there's an elastic collision, they will recede from the center of mass at the same velocity at which they approached it, just in the opposite direction. So, what is the velocity of the van going to be? Well, this van is staying still while the center of mass is approaching it at 0.91 meters per second. And so, after it collides, this will have to be receding from the center of mass at 0.91 meters per second. But since the center of mass is already moving at 0.91 meters per second, the velocity of the van will be 0.91. So 0.91 plus what speed it will be receding it from. So another 0.91. So this is velocity final of the van. And that's just 1.82 meters per second. And that's the velocity of the van. Now for the car, how do we do the car? Well, the car is going to recede the center of mass at 1.34 meters per second, right? But the center of mass is moving at 0.91 meters per second to the right, so it's going to subtract from it. So the velocity final of the car equals to 0.91 minus 1.34. And you can already tell it's going to be negative, and that's because it'll be moving to the left. So 0.91 minus 1.34, and that's negative 0.43 meters per second. And you can check your work by multiplying these velocities by the original mass, see if you get the same amount of momentum in the system. Alright, I hope you learned something in this video. Whoa, wrong tool. I was gonna box my work. There. Alright, I hope you guys learned something. Good luck on your tests and whatnot.